Welcome everybody. This is Mohammad Usman, and today I'm going to talk about my ICP-6, which is text generator using RN layer or LSTM layer. So let's start at this tutorial. Here I am just importing some libraries, and in here I'm just getting database. This is the link where I'm using the datasets of Shakespeare. Here, I'm just trying to decode the read and decode the dataset in Py2 compact, and I'm trying to print some characters from the dataset, and you can see that this is the size of my characters in my file. So I just print some 250 characters of the file. So this is some 250 characters. In here, I'm just printing the unique character in the text. So we got 91 unique characters. So that is the set. The set is used to, this function is a predefined function in the Python, and you can use it to to get the unique character in the text. So, and since I'm using sorted, so you can see that all the unique character are in sorted manner. So, and you also can see that the A is now repeating in the whole in whole set. So it means the A is unique. Okay, moving forward. So before we put our data to the neural network, we just want to we just have to vectorize the text. So it will be easy for model to process it further. So here, what I'm doing, I'm first indexing my character. For indexing, I'm using this function enumerate. So what does enumerate do? It just assign the index to each character in the text. So this is /n belongs to 0, space belongs to 1, exclamation point belongs to 2, and so on. Like you can see that in here. So I is belong to 70. And here the U is my character and I is my number. So this is what I'm doing here. So the next step is to split the tag into training example and target. So here I'm doing the same. Like I'm just defining the sequence. Like this is the length we want for a single input in the character, and this is the example epoch, like the length tag upon sequence length plus 1 and so on. And here we are just slices the tags and into the 5 characters, the 0, 1, 2, 3, 4. So it will take up to 4. The 5, if I put 4, so it will take up to 3. And here, so this method is individually converting the sequence into desired size. So this is the output here, and here we are just splitting our input and target, and we are shifting it. So for example, if we have hello, so it will be ELLO or something like that. I will show you later in the below. And here, so this is my input target and my target. So you can see that. So the one I'm talking about, the shifting, the -1 and 1. So this is the shift it does. Like this is converted to his, and voice, it would be work and convert to O. So here we are creating the training budget. This is the buffer size, this is the batch size. So batch size basically, I want this data to pass from the model back and forth. So it will take it randomly 128 rows and pass from the model and back and forth. This is the buffer size. So we are shuffling the entire sequence, but we are not shuffling the entire sequence memory. So it maintains a buffer in which shuffle elements. And this is the shape I got. Is 128,100. Okay, so if we go down, so like we are building the model, we have a embedding dimension, we have a vocab size, and we are just defining the unit for our LSTM unit. Here, I'm using LSTM and ICP. We use GRU layer, which is recurrent neural network layer. So here I'm just using LSTM. So um, okay, so I'm just using all the same hyperparameter in this layer. I just add the dropout layer 0.2 because I was training without this. So I saw some overfitting. The loss was not decreasing. It was increasing. So I just used the dropout layer. This is my embedding layer. And this is my the final layer, which is dense layer. Okay, so this function just build the model. So we need to try the model before we execute the training. So when we process the model, we see the expected output dimension, which is 12891. So this is the best size, this is a sequence there, and this is the vocab size, which we saw earlier. So this is the summary of my model. So this is the embedding layer, this is the LSTM, this is the dense layer. If we go down, so here I'm just trying to like the first bench. I'm just trying it on my first bench. Okay, so this is the predicted output. Now we are going to execute the training. So here I'm just executing the training, and okay, before execute the training, this is my model. I'm compiling the model. This is an optimizer Adam. This is my loss function. Before executing the training, we need to configure the checkpoint, and we need to save it too during the training. So the function is it's configuring the check, like it's saving it. This is defining the check directory, and it's saving during the training. Here the epoch size is 30. I just changed 10 to 30 because I want to I want to pass my data back and forth from the model 30 times. So if you can see there in the 30 epoch, the loss is 0.99. We can increase more on it. Okay, here we are just generating the text, and like I just try the best size one. So this is the restoring of the checkpoint. Okay, this function is generating the text. This is a model, and this is a starting string, and we want a number of characters to be generated in thousand. And if you go down, and here I just gave the music. This is my starting string, and you can see the output. However, the output is not accurate. The grammar, there are some grammar spelling mistake because of the data set. Data set is not so huge. It is a very small data set. So if you use the big data set, so the result will be very good. So this is the ICP is all about. If you have any question, anything, just let me know, and you can comment in the video, and you can email me. Thank you so much.